Hi, my name is Damian Hill. So for this progress report, we have 3D printed the brackets for a robotic arm. We have a shoulder mount to hold some electronics up on the shoulder, as shown in our CAD model, along with a wrist bracket to hold on the tool to the wrist of the robot, acting as our end effector. In between the electronics over here and down to the wrist, we have a wire harness carrying power and signal for our thermal resistor, our heater, fan, and extruder motor. We can simulate the function of our tool on the robotic arm via software called Robotic. We can try out the extrusion function, heating, and even simulate the motion for 3D printing. Once that simulation is done, we can export that motion path to the robot and begin 3D printing very soon.
Okay, so here we are on site at the actual robot. We have 2 independent agents that are working together simultaneously. One being responsible for the motion, and that is the robot, which has its Robotic program already embedded. And then second, we have our printing system, which is responsible for printing out the material. One, we have our power supply. And then here we have our 3D printed electronic bracket, which mounts both our Raspberry Pi and our control board. And this is connected directly to the extruder and to the hot end, which has another 3D printed shoulder mount that will allow it to attach onto the robot. Now we have these 2 independent agents working together, both for motion, which is the robot with its Robotic, and then one for printing out the material, as shown with the power supply, with the boards and the hot end, all connected together in one system. These 2 independent agents working simultaneously will allow us to create any intended shape or structure.